Okay. As I said earlier in the class, this appendix by Armour is, I came to understand very quickly why Chuck had made this required reading. Because I deal with this stuff in my work as an expert witness. This is such a true factor, this essential difficulty. This, by the way, this is the thing that unless John's going to read here a lot of stuff that he heard last semester. One of the reasons I have been skeptical for 40 plus years about AI is going to take over programming. First, because it frankly has never worked. They've been trying it for 40 years. I mean, I was hearing the same thing 40 years ago. But the other thing is there is an essential creative and inventive aspect. And we have not yet achieved the level of strong AI that can basically do what humans can do with this. So I recognize, how many of you actually were able to read Armour? Hey, a few of you, good for you. Brownie points. I'm not noting it down, okay. One of Armour's key aspects here, and it is an important concept, is that software is actually a knowledge storage medium. We capture knowledge in software. And I'm not talking about databases. Software itself contains knowledge about how to carry out certain processes or tasks and how to do so, hopefully, correctly, with sufficient functionality and in a reasonable amount of time. Those are sort of the three golden aspects. You want functionality, you want performance, you want reliability. Developing software is acquiring knowledge and then encoding it. And because we so often, and especially managers, do not think of software this way. They think of software as building machines, though if you really think about it, sophisticated mechanisms are also a knowledge encoding mechanism. But software is acquiring knowledge, and we seldom have perfect knowledge ahead of time. Why? Let's say that you've written a note application, a little note-taking application. And now you're going to sit down and write the same note application again. Why would you do that? The only reason you'd write it is if you were going to improve it, if you're going to change it, if you're going to increase its functionality, if you're going to improve its speed, if you're going to make it more reliable. Value in software comes from how your software differs from what is already available or what you have already done. But if it's something new, then you don't necessarily know how to do it correctly. Most of us, how many of you had the experience of sitting down to write something and say, oh yeah, I know how to do this. And you get halfway through, it's like, oh crud, there's a lot of stuff here I didn't realize I had to do. Okay, it's my career. We have the phrase in the industry, simple matter of programming. Oh yeah, that's just a simple matter of programming. And we often don't discover, and this is what this whole talk is about, we don't discover what we don't know until we're right in the middle of things. So, software development is an inherently inefficient exploration and discovery process. Why? Because you don't know if you're going to find the answer. You set out to do something, and to the extent that you have unknown information there, you have unknown tasks to accomplish or solutions to find, you have no guarantee you're going to find it. A lot of software companies, a lot of startups die on this hill. How many of you have ever been excited about an announcement of some new technology, some new potential product, something that's going to come out, and then it slips, and then it slips, and then someone buys up the company or the company goes away? How many of you have ever seen that? That's what I call firefly technology. What happens is they thought they had a solution, and they got into it, and they realized they couldn't actually solve the problem in a manner that would matter to the market. Sometimes they release the product and it's more like a lead weight than a Firefly. It's like, yeah, this is here, Taligent, okay? Taligent was going to be the next great operating system and development environment. This was done back in the early 90s. It was a joint between Apple, Hewlett-Packard, and I think IBM. I have to go back and look. It's all in C++. I have a stack. I went to a Taligent development conference. I have a stack of manuals that wide on my bookshelf. It was an utter failure as a commercial product. It was too big, it was too resource intensive, and it didn't solve enough problems. But golly, those manuals look good. How many of you, anyone want to share your own experiences of getting in the middle of a software project and realizing the solution is not coming as fast as you think it should? Yeah.
I currently do that in my job. I'm trying to work with AWS, doing stuff, changing over from Y-Cloud, whatever they call it here, and we just can't seem to figure out how to get through AWS, especially as students.
Yeah.
We don't have the time to do it.
There you go. Other experiences. Yeah.
We, in my research lab, we started a research project in May. And our plan was to finish writing the paper by August, and we're still on phase 2.
And this is the essence of software writing. Sometimes you're lucky. Sometimes you have that brilliant insight when you hit upon something. Other times you find stuff that's really tough. You're going to hear me talk a lot here about Pages. This is a startup I helped found back in 1990, doing a design-oriented desktop publishing system. It was my personal transformation point because we were a full year late in shipping. And that was the most agonizing year of my professional career because I was the CTO and chief architect, and I was part of the ones who had to go to the investors every month and explain why our new deadlines were any more believable than our old ones that we had missed. And it made me question everything I thought I knew about software engineering and project management. And basically put me on my present course. But there are things that you don't think are going to be hard that are hard. Footnotes are really hard. Doing footnotes in a live desktop publishing system where you're constantly reflowing the text are really hard. Rick Gessner, bless his heart, probably lost a couple years of his life just sweating over footnotes, trying to make them work. So what happens along the way? Late discovery. We're going to talk about this a lot. I have one of the articles you'll read is do not defer the difficulty in IT project. Okay. Now, you're starting a new software project. Whether this is on your own, whether this is part of your work, part of your research, whatever. You've got great prototyping tools. You've got some good libraries. You throw up a user interface. You have menus. You have icons. You have lots of stuff that looks good. What's behind that user interface? Nothing, really. A shell. But your manager or your investor, your company looks at it and says, boy, that's really great. When do you have the rest of it working? And you try to say, well, you know, pretty quick. And then you start to dive into all the hard problems. Sometimes you don't know the hard problems are there until you're 6 months in and it's like, oh crap, this is a lot more difficult than I thought it was going to be. Sometimes you have mutually incompatible solutions for different hard problems. There is often late discovery of what the core issues are. And in this process, you learn both what works and what doesn't work. When I was doing Sundog, I had this nifty, I can't even remember what aspect of the game it was, but I had this nifty idea for a type of display of the game. type of information. And I was doing pretty much all the coding, and I spent a couple of weeks doing all this, and finally got it to the point where it was up on the screen, and I looked at it and said, no, that doesn't work at all. And threw it away. And that was 2 weeks. It did not progress the game, other than the fact that I knew what not to do. Now, part of the problem is that how many of you worked on projects where there is turnover, where people, key programmers or developers have left? Okay? And when that person leaves, she or he goes away with a lot of this knowledge of what doesn't work. And those who are left behind end up rediscovering it. They reinvent the flat tire. That this person who left knew not to do because she had already tried it, but those who were behind didn't know not to do that. Corrupted knowledge. How many of you have dealt with source code that has inexplicable chunks of code in it that you look at and say, I don't know what's going on here? Yeah.
And then you delete it and it's fine.
And then you delete it. Yeah, sometimes you delete it, it's fine. I worked as a contract programmer at Apple for a few months. They had bought a multimedia disc back in 1988, which sadly is, I think, before all of you were born. Yes, I'm old. Anyway, they had bought this multimedia package from a third party. They were going to use it for self-running demos on Macintosh computers and stores, and I think for some user tutorials. And they hired me as a programmer to come in and add some features and fix some bugs. And there was this one subroutine that was about, I don't know, 10, 15 pages of Pascal. Had 30 go-to statements in it, jumping back and forth. And it's where all the problems were. And I looked at it and looked at it and tried to tinker with some stuff. And finally, I bit the bullet. It took a couple weeks and basically did a thorough analysis of what it was done and completely rewrote it from scratch. All the bugs went away. And I could just add features like this. You will inherit code that is bad. You will inherit code that in some cases is downright unreadable. In some cases you will inherit code that you don't know whether or not it's even called. Sometimes you can delete it and everything works fine. Sometimes you delete it and the program crashes. And you have to put it back in. And hopefully you've got things controlled enough that you can easily put it back in or easily revert back to changes. People who have had experience with this. Any? Anyone want to offer? Yeah. Oh, yeah.
When I was working over the summer, I was working in automated testing, and at one point during the semester, we were building essentially the API that was working with the web driver that was testing the program. API said other people could just write tests really quickly for it, right? And because there were multiple different teams working on the API, we ended up with 4 or 5 different functions that were essentially doing the same thing. And some person got the bright idea that, oh, I can just keep one and get rid of all the other 4, right? And yeah, it caused a lot of issues.
Yep. Other experiences like this? No. Okay. Trust me. You will have them. So what the discovery path looks like, at least in theory, it's kind of like, okay, you can see the peak of the mountain. You know you need to get there. And you start to work your way through the swamp and the forest. And you find blind alleys. I actually went through this, literally. Back in high school, a group of us decided to climb and lived in East San Diego County. There's a big, not quite a mountain, but almost, called El Capitan. It's not the Yosemite one. In East County, and you can see this big rock massive stretches for miles. And there's some manzanita brush and grasslands at the bottom and so on. A group of us wanted to climb to the top. How many of you have ever lived in Southern California? How many of you are familiar with manzanita? Okay, manzanita is this gorgeous wood, but boy, it is tough as nails and it has thorns. And so we're trying to get our way, push our way through these manzanita growths, and we basically got lost trying to get to the top of the mountain. We finally got close enough, and then we actually couldn't find our way back down, so we had to go down the far side. And then someone went miles, basically hitchhiked miles around in the front of the mountain to get our car and come back and pick us all up. A lot of software development was like that. As you can see, so, well, yeah, we're just trying to do this. This is what we want to do. And you start going through there, and you get lost in the weeds. You find things that work and things that don't work. Armour, when you read it, will show that you have knowledge that you acquire of things that don't work. That's what the dotted lines are. Dotted lines is what he calls unknowledge. It's things, paths that you go on that you basically abandon because you realize that process isn't working. The solid line is where it is working, but even that isn't quite straightforward. So what you have is something that rather than a straight line from left to right, you have all these blind alleys, you have all these efforts that you discard. Hopefully you remember that you didn't do it. A lot of organizations will not document, as I said, will not document the stuff that didn't work. And when you have turnover, people end up reinventing it.
I was a little confused on the graph. When the lines go down, or, well, they only go down, they don't go left, but what does it mean for it to go down on the time spent finding enough? That seems like unspent time.
Basically, I think what he's trying to say here is sometimes your progress is fast, sometimes it's slow. You know, progress typically is left to right here. Sometimes it takes us a long time to make a little progress. Other times you get straighter lines and you're actually making progress much faster than what you're trying to do. Now, you may be doing the correct thing, but you're doing the correct thing, but it's taking a long time to get there, to get things to work. Good question. So he talks about 5 quarters of ignorance. He gets sort of metaphysical on the fourth one. First is, you know something, you know that you know it, you can demonstrate that you know it. Second one is, I don't know something and I know I don't know it. Stop and think about a problem that you would like to solve in programming. And you say, okay, to solve this problem in programming, I'm going to have to be able to do A, B, and C. I know how to do A and B. I don't know how to do C yet, but I know that I'm going to have to figure out how to do C. That's sort of how we tend to envision most of our software projects. But then we get to the second order, I don't know something and I don't know that I don't know it. This is I'm doing the project and I don't realize that in order to complete my project, I'm going to have to do X. I'm not even aware of X. Now, at some point in the project, I become aware of X. And it's like, oh my gosh, this is something entirely new that I'm going to have to accomplish. You're nodding your head or thinking, yeah, that's our research project. That is the nature of research. That is the nature of, we know what we want to do, and along the way, you discover the things you didn't realize you're going to have to accomplish. Finish that project. We have a lot of that. Frankly, I had a lot of that in Sundog because we were doing a game, and it's kind of like, I wrote the graphics library from scratch. This was sort of a bare metal up project. And it's kind of like, okay, I've got to do this, This is how I have to detect collisions on the screen. I have to write that from scratch and figure out what will work, try it out, get it working. The third order is I lack a process by which I can discover that I don't know something. This is this basically says, and he puts it, I lack a process. I would say you're often constrained. In other words, you're in an environment, software engineering, you're in an environment where you're being told what to do and you're not being allowed to do the research and exploration necessary to discover what you don't know to complete the project. You're being mandated, just make this work this way. It can't work that way. Well, just make it work that way. It can't. I've had some of those arguments. Yes.
Could you call third order lack of ability to find second order problems?
It could be, though it's more a process. I mean, you know, when it says I lack a process, I think most people are able to find, eventually try, you know, unless you're really just not skilled at all. We will talk about the issues of talent, knowledge, education, experience, and so on in software engineering. Yeah, there are some people who just can't program, just like there's some people who can't really dance. You know, I'm great at math, I'm great at programming. My freshman year, I signed up for Music Theory 101 for non-music majors, and I dropped it after 2 weeks because none of it was sticking to my brain. And that in spite of having been in the choir for 2.5 years in high school. There are people, and by the way, I'll talk a lot in here about talent, and usually what I start to get are sort of slightly panicked questions from my students saying, what if I'm not talented enough? If you made it to your senior year with a computer science program, you're talented enough. Go out and have a successful career as a software engineer, trust me. But I remember a roommate I had my first year in computer science who was a business major who had a programming class and kept coming to me for help, and I tried to explain the simplest things, and he's a good guy, bright guy, but boy, it would not stick to his brain at all. I pretty much had to hold his hand getting through the programming assignment. How many of you have had that experience helping? Yeah, okay, so you know what I'm talking about. So, yes, there are some people who actually really sort of can't even be, can't be aware that they need to find this stuff out. Meta-ignorance, I don't know about the 5 words of ignorance, you all know about it now. And I was sort of dismissive of this, but you know, this is a problem with a lot of IT management. They don't recognize these orders of ignorance. And as such, they are not willing to deal with the difficulties of actually figuring out what you don't know and then learning it. Yeah.
So this meta-ignorance more like hubris, I think people are unable to like come to terms with the fact that they don't know things?
Well, it could be that, but in some cases, it's just like, well, you know, it's programming, just do it. Most of you have probably who've done programming, have had this experience. First, how many of you have ever, you've got some code working, doing something, and someone says, can you make it do X? And you go, yeah, do this, and bam, it works, and you're all impressed. How many of you have had that rush? Putting in a feature like, you know, in 5 minutes, and they're so impressed. And then they say, can you make it do Y? And you say, well, no, I can't. Well, why not? You just made it do X. Well, then Y is completely different. Well, why is it different? Well, it's kind of hard to explain. But this was really simple, and this is really hard. This is what drives managers nuts about software engineering. They don't explain. They don't understand that some things are actually very simple to expand, and some things are very hard. One of the biggest problems that you can have is succeeding too quickly and too well in the software project. I actually was called in to Capital One on a project. They were doing a brand new version of their customer-facing website for credit card holders. And they sort of had impossible deadlines for version 1.0. And the development team there in-house, bless their hearts, launched on schedule. And the management said, great, do it again for 2.0, and here's all the things we want to add. And the developers were like, no, you don't understand. This is chewing gum and baling wire. We have tremendous technical debt here. And management was like, well, I don't know. You did 1.0 on schedule. Why can't you do this? And I was part of a group that came in with OSG and basically said, no, back off. It was a miracle that they did 1.0. Don't expect 2 miracles. You know, give them a chance to clean up all the quick and dirty stuff they did to make the 1.0 deadline. Don't try to make them build 2.0 on top of that. Okay, so applied software development. I know how to complete the system in zero order. I know everything I need to do to finish it. Now sometimes we're zero order, but we don't realize that we're not really zero order. First order, I know what I need to know to complete the system. I've got to research this, I've got to figure out this, I've got to learn how to use this API, I can do this. Second order, I don't know yet what I will need to know to complete the system. That's a good point to start from, to assume at the start that you don't know everything that you're going to need to know to complete the system. Third order, sometimes you will find yourself in this. It's kind of like, you know, I don't know how to complete the system, and I'm not sure if I can complete the system. I'm not sure if the system can be built. Trust me, you will find yourself working in organizations where you're given impossible tasks. Fourth order, I have no clue about any of the issues above. This is a cycle. Read the article, by the way. My lectures are not intended to replace reading. They're intended simply to allow for some discussion of it. So, what's our process is we need to identify where we have ignorance, where we might have ignorance, what we need to do to resolve it, and how to acquire that information. I will come back to Armour time and time again throughout this course, because you will find that this underpins a lot of the core issues of software engineering, particularly a lot of the core problems. It is a reason why a lot of projects fail, because people really don't know what they don't know. And they don't really, in some cases you have managers who are imposing impossible deadlines. Any more thoughts before, I think that's the end of the lecture. I've got more slides. Yeah.
Yeah, so how do you like deal with if you have had to meet a really tough deadline and then you did it, how do you deal with like managing expectations?
Oh, God. You know, it's hard. And I say this because, you know, I did this thing at Capital One. I saw the same thing. My daughter went through this at a software company. She's a software, I have a daughter who's a software company. Actually, about half her kids work in IT. Bless their hearts. My daughter's a software engineer, and there was a project. It was much like what I described. It was a project, much like the one at Capital One, where she and her small team did a lot of very non-scalable, quick and dirty stuff to get sort of the initial version, proof of concept up. And the company came back and said, great, we need now to do this for 10 times the user base. And she said, it won't work. And she basically just had to keep saying, it won't work, it won't work, it won't work. I don't know how she finally resolved it. Maybe in that they simply expanded the base and found it didn't work. They had to shift to different database technology. It's hard. It's hard, and it's one of the things you'll discover is that there is sort of an inherent conflict between management and IT. We'll talk a lot about that, especially between marketing and IT. I've had shouting matches and promised them what? The product doesn't do that. We can't make it do that. Well, I told them. I told the NSA we could do that. No, we can't do it, Rand. We cannot do it. I don't care what you told the NSA. We cannot do that. Literally, I had that shouting match. Yes.
Were you able to bring the Capital One manager to the knowledge that the push deadlines, I'm assuming that the technical debt you're talking about was short-term gains in order to reach the goal, which actually made it harder to improve the software?
Actually, it was mostly sort of like, oh yeah, we just want this now. Yes, our team was actually able, we pointed out all the risks. We pointed out the issues. They actually had a great, Capital One had a great IT organization in front. It was upper management that we needed to basically say, look, back off, here are the risks, they are managing this well, trust them, break this up into a series. I think we proposed 3 phases for the features they wanted. So this will give them a chance to retire a lot of the technical debt while adding features on an incremental basis rather than doing this 2.0 big bang that was doomed to fail. And they actually listened to us. Not always my experience, including in Capital One. We'll talk more about that later. Yeah?
When you say technical debt, are you talking about things that they did, implemented maybe poorly just to get it done?
Oh yeah.
That they had to fix?
Yeah. Oh yeah. Technical debt, by technical debt, it's basically doing stuff just to make it work and get it out the door, knowing that you're going to have to go back and clean it up. It's either poor design, it's not scalable, it's masking certain bugs, stuff like that. We'll talk about technical debt a lot. Yeah.
I guess this is just things about the reading in general.
Oh.
Is that right?
Yeah.
I was just, when I was reading, one of the claims, at first I thought was wrong, but then I realized it wasn't, where he said that we had no way of quantifying knowledge.
Mhm.
At first I thought that was wrong, because there's bits and bytes, and I realized that they meant knowledge versus unknowledge.
Yeah. And there really isn't. Here's your assignment for the week. Okay, I need your email for GitHub. You can do that to my email. You can do it to me on Slack. You can do it to Sean on Slack. Make Sean earn his money. You need to join Slack. If you haven't already, most of you are on there. I think we're up to 70-something. Read Armour if you haven't. Read chapters 1, 2, 4, and 5 of Brooks. You read 3 if you want. And start creating your proposed projects. Now's the time to dive in and start creating pages once you're on the GitHub wiki. Start creating pages for your projects. Or if you've already forming groups, I know some of you already have projects you want to do together or whatever, or if you see one you like, say, I'm very interested in this project. Yes? A few more questions.
So are we supposed to endorse only one project?
Oh, no, you can endorse as many as you want.
And if we endorse it, are we basically kind of pledging to be on it?
No, because we'll do the voting. We'll do the voting for which projects you want to be on, because a lot of projects won't survive the cut. Yes? Projects. Guys, sit down. Come on. I can keep you here for another half hour, you know. Don't test me. You asked how many people on projects. Typically, we've said 6 to 9. 9 is kind of big. I had some complaints with some of the bigger projects that a lot of people really didn't have anything to do. We had some smaller projects last semester, and I was fine with that. So I'm going to say, let's aim 4 to 7 on a project. And a lot of what we'll do next week is go through the proposed projects, let people vote on them, and this is sort of, we'll do multiple rounds of voting to get people distributed among the projects. It's, we've got a lot of people here to deal with too. So, got 1 or 2 other questions? Yes?
Are we supposed to our name somewhere for endorsing it? Or like?
Yeah, just go to the page, edit it, and put your name in there.
Okay.
So we know. Yeah.
An endorsement list is on.
Yeah, just or just stick your name and sort of say I endorse this or whatever. Okay, that's fine. Any other questions before you all leave us? Okay, I'll see you in a week. Contact me on Slack if you have questions.